Hello students, I am Karishma from Solvio and today I am going to discuss the topic of Maclaurin's expansion of functions of two variables. So students, Maclaurin expansion of functions of two variables is a special case of our Taylor series. Here the point a comma b is equal to 0 comma 0. So the Maclaurin series is given by f of x comma y is equal to f at 0 comma 0 plus 1 upon 1 factorial times x into fx at 0 comma 0 plus y into fy at 0 comma 0. Here fx is first order partial derivative of function f with respect to x and fy is first order partial derivative of a function f with respect to y plus 1 upon 2 factorial times x square into fxx at 0 comma 0 plus twice of fxy into fxy at 0 comma 0 plus y square into fyy at 0 comma 0, where fxx is second order partial derivative of function f with respect to x and fyy is second order partial derivative of function f with respect to y. And in fxy, we will firstly partially differentiate f with respect to x and then we will differentiate fx with respect to y plus 1 upon 3 factorial times x cube into third order partial derivative of our function f with respect to x at 0 comma 0 plus y cube times third order partial derivative of our function f with respect to y at point 0 comma 0 plus 3x square y into fxxy at 0 comma 0 plus 3xy square times fxyy at 0 comma 0. In case of fxxy, firstly you will differentiate f twice with respect to x and then you will differentiate fxx with respect to y. In case of fxyy, firstly you will differentiate f with respect to x and then you will differentiate fx with respect to y twice at point 0 comma 0 plus so on. Now we will discuss one example related to the concept. Here we need to expand e raised to power x log of 1 plus x in power of x and y up to terms of second degree. That means we need to write Maclaurin's expansion up to the second order derivative terms, that is up to here. Right? So let's start the solution. So students, here are f of x comma y is equal to e raised to power x log of 1 plus y. Right? Now, as you have seen in the expansion that we need the first order partial derivatives of function f as well as second order partial derivatives of a function f. So, firstly we will compute those values and then we will substitute those values in order to get our Maclaurin series. Okay. So, firstly you will differentiate function f with respect to x. So, that is fx is equal to, it becomes e raised to power x into log of 1 plus y. Here we have differentiated f with respect to x partially keeping y constant. Now you need to find fy, that is first order partial differentiation of function f with respect to y keeping x constant. So it becomes e raised to power x times 1 upon 1 plus y. Right? So that is equal to e raised to power x upon 1 plus y. Clear? And we need to find all these values at point 0 comma 0. So simultaneously we will find that values also. So f of x at 0 comma 0 is equal to, you will substitute here 0 comma 0, it becomes e raised to power 0 1 times log of 1 will be 0. Now fy at 0 comma 0 will be equal to, substitute x and y as 0, it becomes 1. Right? 1 upon 1 will be equal to 1. Now we need to evaluate second order partial derivatives of our function. That is f of x comma x, that will be equal to, here you will differentiate fx again with respect to x. So it becomes equal to e raised to power x into log of 1 plus y. Now put xy equal to 0 comma 0, it becomes f of x comma x at 0 comma 0 will be equal to 0 because log 1 is 0. Now you need to find fxy. Here you need to differentiate fx again with respect to y. So it becomes e raised to power x divided by 1 plus y. Now the value of f x comma y at 0 comma 0 will be equal to, it becomes 1 upon 1, 1. Clear? Now I need to find second order partial derivative of function f with respect to y, that will be equal to, here you will differentiate fy again with respect to y. So it becomes e raised to power x time minus 1 upon 1 plus y whole square, and that is equal to minus e raised to power x whole divided by 1 plus y whole square. Now you need to find its value at the point 0 comma 0, and it becomes minus 1 upon 1, that is minus 1. Clear? Now we will substitute all the values in our Maclaurin's expansion. Clear? Now the general Maclaurin expansion at any point x comma y is equal to f of 0 comma 0 plus 1 upon 1 factorial times x into fx at 0 comma 0 plus y into fy at 0 comma 0 plus 1 upon 2 factorial times x square into fxx at 0 comma 0 plus twice of x into y into fx y at 0 comma 0, right, plus y square fyy at 0 comma 0 plus so on, right. Now we need to substitute all the values, that is f of 0 0, that will be e raised to power 0 plus log of 1, that will be equal to 0. So f of x comma y equal to 0 plus 1 upon 1 factorial times x into fx at 0 comma 0 is 0, right, plus y times fy at 0 comma 0 here, which is 1, bracket close, plus 1 upon 2 factorial times x square into second order partial derivative of f with respect to x at 0 comma 0, that is also 0, plus twice of x into y fxy at 0 comma 0 is 1, plus y square times fyy at 0 comma 0 is minus 1 plus so on, right. So I have substituted all the values. Now we got f of x comma y is equal to 1 upon 1 factorial is 1, x into 0 0 plus y. So this is y plus 1 upon 2 factorial means 1 upon 2 times twice of x into y. This term is 0. This becomes twice of xy minus y square plus so. So this is the answer of our example. I hope that all the steps are clear to you, and if you want me to discuss more examples related to the concept, so you can visit our website, that is www.solvio.co.in, and thank you so much for connecting with us. Thank you.